Hello everyone, my name is Han and I'm from GraphCore. I'm honored to have this opportunity to share something. Today, I will share how to support the ONNX model on the IPU processor. The PopART, also we called PopONNX internally, is a framework that we can enable ONNX model for IPU. First of all, let me introduce my company GraphCore. Put simply, GraphCore develops AI processor specifically designed for AI and machine learning workloads, called IPU. We provide hardware and software and platforms as part of a complete solution to enable innovators to solve current and future machine learning problems. We have announced our second generation IPU processor, the GC200. Each GC200 processor has nearly 1,500 processor cores. Inside the processor, we have been able to fit 900 MB of high-speed RAM. And also we have announced our new product, the IPU M2000 system, which consists of 4 GC200 IPU processors. Multiple IPU M2000 can be directly connected to build large-scale IPU pod system. Let's introduce our software stack. The bottom layer is our popular graph library, contains graph engine and graph compiler. Its upper layer is the framework layer, including the PopART framework and the XLA plugin for supporting TensorFlow. So what is the PopART? The full name of PopART is Popular Advanced Runtime. PopART can load and execute ONNX model on IPU, support ONNX IR version 4, OP side versions from 6 to 11, support both inference and training, provide C++ and Python API. In addition to directly loading ONNX model, it also provides Builder API, which can build any model programmatically. Let me show you two examples to illustrate how to program with PopART. Let's start with an inference example first. You can see the model structure in the right. Two inputs, x and y, running through an add operation, which produce a simple output called sum. So first of all, we create an inference session. We give the ONNX model name to model argument. Then we create a data flow object to tell PopART that which node is the output node. And the batches per step means that how many batches of data will be processed in IPU before returning the result back to host. We require only one IPU device through Device Manager. Once we created the session, we use init anchor arrays to initialize the host buffer to store the result. And the important one is line 14 that we call the prepare device. It did a lot of work, include performing graph optimization and compile, and loading graph onto the device. Once it has completed, your IPU is ready to execute. Next, we create some random data. And then we invoke the session run method. We give it the py_step_io. Py_step_io is used to map the input-output tensor name with the host data buffer. So that call will execute on the IPU, send the input data from host to the IPU, and finally we get the result. The result will store to the host buffer. So how do we support training for ONNX model? When we started the PopART project several years ago, ONNX didn't support training yet. What we got was a forward inference graph. We manually add label node and loss function node to the inference graph, and then the PopART adds the backward node for each forward node automatically. Finally, with update node will also be added into the graph. In this way, we finally got the graph for training. And this is the code example for training. And you can find that the code structure is pretty much the same as inference. So, this time, rather than pass the ONNX file directly into session, we use the builder class to load model. Then we add the softmax node to the end of the model, and then add label tensor for the loss. The important change is here. Instead using inference session, we use training session, and we need to configure the loss function and the optimizer. Again, we call the prepare device to compile and load graph. These two lines here enable us to copy weights from the host into the IPU, and also the tensors associated with the optimizer into the IPU. Finally, we create a loop to perform the session run. Also, we can save the model back into a file by calling this function. Let me introduce some useful features in PopART. PopART supports data parallelism through replica technology. It copies the same model into multiple IPUs. Each IPU receives different training data and use our reduce to update the weights globally. If a model is too large to fit in a single IPU, we can use sharding technology to split a model into multiple IPU. When the model is executed, each batch of data will go through a V shape across multiple IPU from forward to backward. But we can see that the utilization of IPU is quite low because only one IPU is working at each moment and other IPUs are waiting. So in order to improve IPU utilization, PopART supports pipelining technology. For each batch of data, it still has to go through a V shape from forward to backward, but unlike sharding, the data of the next batch can be consumed before the current batch is completed, so multiple batches of data can be executed in parallel. After the warm-up stage, the IPU utilization reaches 100%. Okay, that's all. By the way, PopART is already open source. You can get more information through our GraphCore website and GitHub. You can also send me email if there's any question. Thank you.